Okay, let's take a look at question number 10. The equation x to the 4 plus x cubed plus cx squared plus 4x minus 2 squared to 0, where c is a constant, has roots alpha, beta, gamma, and delta. Use the substitution 1 over x, y is equal to 1 over x to find an equation which has roots 1 over alpha, 1 over beta, and 1 over gamma, and 1 over delta. Alright, now let's do this part by part. I will try and do the first part by substituting like the saying, y is equal to 1 over x, which means that x is equal to 1 over y. So if we were to substitute 1 over y into the equation, it will become like this. And of course, you do all the algebra, you will reach something like that. And going further, you just cross multiply and multiply the denominators, and you do the same for this part as well, which becomes then cy plus 4y squared divided by y to the cube. And of course minus 2 is equal to 0. And now from here we keep on moving. So this times that, okay, and this times that. Y to the 7 times y to the 3 is y to the 10 times minus 2 is minus 2y to the 10, and all of that should be equal to 0. Simplifying, the y cube can go outside, and what I'm left inside is all of that expression. And I think this disappears when it goes on the other side, divides by 0, and you can further simplify into y to the 4, which can go outside, and then well, that's y to the 4 plus y to the cube. Okay, this if you multiply this out, y to the 5 times c plus y to this, 4y to the 6, okay, minus 2y to the 7 is equal to 0. Y cube can be factorized, can be factored out. Cy to the 2, because 5 minus 3 is 2, plus 4y to the 3, then minus 2y to the 7 minus 3 is 4 is equal to 0. This leads to this y cube can disappear. I've got minus 2y to the 4, okay, plus all of that expression there. And you can multiply by minus 1 on both sides. You will reach 2y to the 4 minus 4y cubed minus cy to the square minus y minus 1 is equal to 0. Now we have shown that this equation can have these roots, okay, alpha, beta, gamma, which has roots this, okay, by using this substitution. Now find in terms of c the values of alpha square plus beta square plus gamma square plus delta square. Now what is that one? Okay, so for the second part, this is the first part. We are attempting to find alpha square plus beta square plus gamma square plus delta square. Now for this part, we should remember that this is basically using the recurrence formula, s1 to the square minus 2, the summation, the sum of alpha beta. And if we do that, what is S1 from this equation? From this equation we clearly see that S1 is -1. So -1 to the square minus 2 times alpha beta. And what is alpha beta? Is going to be C over 1. So which is then C. Alright, so what we have then is 1 minus 2C. So therefore we're saying that S2 is equal to 1 minus 2C, which is basically all of that. And now for the other part of the question, this becomes a little bit more complicated. 1 over alpha square, 1 over beta square, and all of that. So we're going to do that just now. Now, to be able to find the sum of 1 over alpha square plus 1 over beta square and so on, we need to understand that this is basically using the recurrence formula s to the minus 2. Now, the first thing to do here is to look at the equation itself. We're looking at x power 4 plus x power 3 plus cx square plus 4x minus 2 is equal to 0. So what is the first step here? I'm going to divide by x square. Okay, so we're going to get x to the 2, alright, plus then x plus c plus 4x to the power minus 1 minus 2x to the power minus 2. And then from here I'm going to use the recurrence formula. And when we use the recurrence formula again, s2 plus s1 plus c, alright, and basically we are saying 4c. Why? Because there's 4 roots, okay, so 4, the constant is multiplied by 4, and plus 4s to the minus 1 minus 2s to the minus 2. And if you look carefully, this, all of that's going to be equal to 0, so this can go on the other side, so we have 2s minus 2 is equal to s2. And what is s2? s2 was found to be 1 minus 2c, so we're going to say 1 minus 2c, alright, plus s1, and s1 is basically here, 1 divided by this is going to be equal to minus 1, so plus minus 1, okay, which is b minus b over a, alright, plus 4c, okay, and then we have 4 times s minus 2, 2 times s minus 2, this is on the other side, 4c plus 4s1, s minus 1. What is s minus 1? Basically s minus 1 is 4 divided by minus 2. You take the linear, the negative of the linear, divide by this, so that's going to become 2 then. Alright, so this is 4 times 2 basically. Okay, so what we have is 2s to the minus 2 is equal to, the 1 and the 1 can disappear, and I've got 8 minus 2c, so 8 minus 2c. So we're saying that s to the minus 2 is equal to this divided by 2 is going to be equal to then plus the 4c. Where's the 4c? Where has it gone? Minus 2c plus 4c. Okay. So that becomes then 2c, okay, plus 8 divided by 2, which becomes c plus 4. And that should be the answer to this part of the question, the summation of all of that. Now then, for the third part of the question, we're looking at this part here. We need to find the sum of alpha minus 1 over alpha square plus 1 plus beta minus 1 over beta, all of that to the square, and so on. Now basically we're dealing with a quadratic expansion of each of these roots, and therefore rewriting them as such is going to be like this. And therefore if we were to expand this one here, we should be able to get, okay, this is 4 roots of the same equation. You can pick any of those, okay, and therefore you're going to get alpha square minus 2 alpha times alpha to the minus 2 plus alpha to the minus 2. Just do the quadratic expansion of that. And this is the same as the summation of alpha square plus the summation of, sum of alpha minus 2 and of course minus 2 times, what is alpha negative 1, I'm supposed to be put negative 1 here, that's going to be alpha to the 0, times the 2 is going to be equal to 2, but you have to multiply by 4 to get 8. Why? Because we have 4 roots, remember, so 4 roots, so minus, therefore we're going to minus 8. And from here, we know that this one was found earlier in the first part of the question, and it was found to be 1 minus 2c. And as for that one, we just found it to be s minus 2, which is c plus 4, and then minus the 8. If you add this up, you should be able to get minus c minus 3. And so this is the third part of the question. Now for the last part of the question, which is part 4 of the question, deduce that when c is equal to minus 3, the roots of the given equation are not all real. 3 marks. Now, if c is equal to minus 3, what are we saying then? That alpha minus alpha to the minus 1 to the square is equal to, c is equal to minus 3. So minus 3 minus 3, which is then 0. That means if you solve for alpha, you should be able to get the square root of 0, and then alpha minus alpha to the minus 1 is equal to 0, which leads to alpha is equal to plus or minus 1. And, well, you can do the, this is basically what we're doing, alpha to them times alpha is alpha square 0 minus 1. So alpha square minus 1 is equal to 0, alpha is equal to plus or minus 1. Okay, now what about this? This would be the same for beta, it would be the same for gamma, it would be the same for delta. All of them is going to be equal to plus or minus 1. But when we look at the equation carefully, since the beginning, there's a minus 2 here. What is that minus 2? What does that mean? Basically, minus 2 is alpha, beta, gamma, delta is equal to minus 2. But if alpha, beta, gamma, and all of that's going to plus or equal to minus 1, it doesn't correspond. The sum, the product of these roots is not leading to minus 2, because if you take 1 times 1 times 1 times 1, you should be able to get 1. And therefore that doesn't correspond. It's impossible, right? So this is impossible. So therefore this has been shown that the roots of the given equation are not all real. Roots of the equation are therefore not all real. There is a contradiction here. Okay, so here we are for this question. Let me just put it nicely for you to be able to see. So that's it. This one here. Okay. So this is coming from the June 2013, the Further Maths code 931, and then this is from the June, alright, 2013. Okay, I'm sorry about the noise in the background. This is uncontrollable because the neighbors have got dogs and all of them are barking at this point in time. Take care.